So we're going to pressure, volume and gas, change in temperature when the temperature changes. So we've given question like this. A gas sample has a volume of 178 milliliters at 0.00 degrees Celsius. The temperature is raised at constant pressure until the volume reaches 211 milliliters. What is the temperature of the gas sample? So when you have a question like this, right, to know what equation to use quick, once you see there's a change in something, they say the temperature changes when you're given all the factors to calculate, like you use the m, v is equal to nRT over p, right? But here there's a change in something, means that in order for this to work, you have to change one thing and keep the rest constant. So here is the gas sample, the volume of that, the temperature raises, and they want to know what happens to the volume. So there's a relationship between volume and temperature. So you use the volume and temperature equation. So we know that using common sense, we could say that as the temperature of something increases, the volume of something increases. So that means that volume is directly proportional to temperature. So because of that, you bring the T on this side, you get V1 over T1 is equal to V2 over T2. That's how you get this equation. So we get V1 over T1 is equal to V2 over T2. We need to find T2 because we want to find the final temperature when the volume increases. So we know that from here, we know that the final volume is 211, right? So 211 milliliters. The temperature is 0 degrees Celsius and the volume is 178 milliliters. So you don't have to change the liters because this and this would cancel, so you can leave it the same. Now they want the answer in degrees Celsius, so you don't have to change the degrees. So you put it in, you get T2 is equal to this over here. Notice that when it's in degrees, when you multiply 211 multiply by 0, if you were to multiply this by 0, you will get 0. So this is not going to work. So in order for this to work, you'd have to convert to kelvins. See here? So in order to convert to kelvins, you'd have to add 273 degrees to it. So you get 0 add 273 degrees is 273 kelvins. So now you can do the equation. This and this cancels, you get 323.6 kelvins. Now that you get in kelvins, you convert it back into degrees. So just add 273 to get kelvins minus 273 degrees to get back in degrees. So you get 50.6, so you round it off, you get 51 degrees Celsius.